Hello students, this is Coach Holliday, and today we're going to be working on a lesson on domain and range of line segments. We've already done domain and range in a couple of other lessons back in the last unit, but we're going to go ahead and continue that today, and we're going to talk about continuous types of functions. So what I need you to do is I need you to take your notes out and follow along with me. If you have any need to pause the video, please do that and continue from there. Alright, so let's start with some definitions. Our first definition is the word discrete. What discrete is, when I talk about discrete data or a discrete graph, it talks about points that are on a coordinate plane, and those points have gaps, breaks, pauses, or some kind of whole spacing in between them. Okay, an example of that would be a graph like what you see on our paper or on the screen, and it has 5 specific points on here. This is discrete data because there's gaps in between each of the points. Now we also have continuous type graphs. Continuous graphs are a little different than what you've seen so far that we found in domain and range. With a continuous graph, alright, continuous graph has an unbroken line or a curve that doesn't have any gaps or breaks in it. It could start and it could stop, but it's not going to have any gaps in between it. An example of continuous graph would be this graph that you see here on the screen. You'll notice that it has an endpoint, another endpoint, and it's continuous with no breaks in it from one endpoint to the other endpoint. Now it doesn't have to have endpoints. It can go forever in left or right or up or down, but in this case the ones we're going to look at today will have these endpoints. Now the next definition is domain. You should be very familiar with that. Domain just means all of the x value that we're going to use on the graph, and particularly you're going to notice that we're going to read these from left to right when we write our domain today. And then the last part is range, and range is all of the y values in the graph that the graph uses, and that's going to be read from the bottom of the graph to the top of the graph, and you'll see what I mean as I get going through the example. Okay, so let's go ahead and find the domain and range. The very first example we have should be very easy for you. As a matter of fact, it's a review. This is a discrete data, and this is what we were tested on in the last unit. So I'd like you to take just a moment, go through, find the domain and range, and then also tell if the graph is a function. When you get all that done, go ahead and start. So we'll pause the video. When you get that done, start the video back up and see how you did. Okay, you'll see that the domain is -8, -5, -1, 4, and 8, and notice I wrote that with the set brackets, and I wrote each value with a comma in between it. The range is -7, -5, 0, 2, and 5. Did the same thing there, and in both of those actually wrote them from least to greatest like you should. This is not a function because first of all it passes the vertical line test, and then we can also see from the order pairs that none of the x's repeat themselves. So this again was an example of a discrete graph. Now we're going to, which should be a review. Now we're going to look at the continuous graphs, which will be some new stuff for you. Right, this is an example of a continuous graph, and you'll notice that it's made up first of an endpoint on the left, an endpoint on the right, and then it's got a solid line in between. And remember, this solid line just basically is a bunch of points that are so close together that they end up making what looks like a solid line. So if I wanted to write the domain, I could not write all of those ordered pairs, or the range either, because I couldn't write all the ordered pairs for those. So what I'm going to do is I'm going to specify an interval, and I'll show you how we're going to do that. Okay, so the first thing I want you to do is we're going to make boundaries in this graph. So what we're going to do is we're going to look to the left. We're going to start from the left of the graph, and we're going to work our way looking from the left until we finally touch a point that's on that graph, on our segment. Okay, so our segment comes to there, and I'm just going to go ahead and draw a vertical line all the way down that. Now that vertical line is at x equals -1, 2, 3, 4, 5, 6, 7, 8. So this is x equals -8. Alright, and now I'm going to go to the right of the graph, and I'm going to work my way back until I come across the edge of the graph, which is right here, the edge of our line segment. Alright, and that point is where x is positive 2. So there's nothing out here to the right. There's nothing over here to the left. All of our points, or all of our graph, is in between these two lines. So if you'll notice, those two lines give us a segment on our x-axis. They give us a segment on our x-axis. And that segment is between -8 and 2. So the way I do this, I'm going to write this in what we call interval notation. So to do the domain, I'm going to write my set brackets. I'm going to put x right in the middle because x is my for domain. And my domain is going to start at -8. That's my left boundary. So I'm going to write -8 here on the left side and leave a little space. And then my right boundary is 2. So I'm going to put the 2 over here on the right side. Now x is between -8 and 2. So what we use is we use the inequality less than. Okay, and what that means is x is less than 2, so it's less than 2, and x is greater than -8, so it's greater than -8, so it's in between that area. Now the last thing I got to look at is you'll notice that on each of the boundaries we have a closed dot. Remember, we have a closed dot that does include the point, so I have to put an equals. And this is written now in what we call inequality notation. And the reason why we have to write it like this is because our graph is of a continuous nature. Okay? Now we're going to do the range the same way. I'm going to pause for just a second and change some colors and take some stuff off the graph. Okay, so I've cleared my graph so I can do the range. Now for the range, I'm going to start at the bottom of the graph and work my way up until I get to the edge of my function or my picture. Draw a horizontal line there, and that's actually at 1, 2, 3, 4. That's at -4. And then I'm going to do the same thing from the top, work my way down until I get to my graph. I'm going to draw a line all the way across, and that line is at +1. Now I don't have any points up here. I don't have any points down here, so I can forget about those areas. And notice I'm just in between these. And notice this actually gives me a segment on my y-axis that goes from -4 to +1. So I'm going to do the same thing I did for my domain, and I'm going to write my range. I'm going to put my set brackets. Instead of putting an x, I'm going to put a y because the range starts with y, or talks about the y. And I'm going to go ahead and put the inequalities less than. I always use less than on both of these. And then I'm going to write in my boundary. My lower boundary, my small boundary is -4, and my high boundary or my upper boundary is 1. And the last thing is I need to notice that I have a solid dot on the bottom and top, so I'm going to use the equal part also there. The way I say this is y is between -4 and 1. Notice y is less than or equal to 1, so it's down here. And y is greater than or equal to -4, so it's greater than or equal to that, so that's the area it specifies there. So that is my range. I know this is a function. If I just do the vertical line test, it'll tell me it's a function. Okay? So hopefully you understood that a little bit. I want you to see if you can at least start this next one on your own. And then, so pause the video, see if you can start it by writing the domain and the range, and then turn on the video and we'll go through the answer for you. Okay, so I've started the domain for you, and if you'll notice the domain, the left boundary is -6, the right boundary is 4. So I'll put -6 on the left side and +4 on the right side. I always use less than, and then I got to see if the endpoints are open, which means they are not included, or closed, which they're included. So if I look at the one with -6, notice it's an open boundary, it's an open dot, so I leave it just less than. On the right side with the 4 though, notice I have a solid dot, so that has to have the equal part into it also. Okay? Alright, now go ahead and pause the video again, see if you can do the range, and I'll come back and explain that. Okay, so for the range, if you'll notice, sorry about that, if you'll notice for the range that the lower boundary starts at -2, that's the bottom part. The top boundary goes to 6, so I'm going to use Y. I'm going to put the less than on both sides. I'm going to put the smallest number on the left, 2, the largest number on the right, 6. And notice with the -2, it's an open dot. Since it's an open dot, it just stays with the less than, because that point's not included in the domain. But with the 6, if you'll notice, it's a closed dot, so I have to put the equal part there. Okay? And this is a function. If I do the vertical line test, it's going to be a function on there. Okay? Hopefully this made sense to you. We're going to spend a lot of time on it in class over actually the next couple days. So go ahead and answer the WISC, and we'll see you in class to work on some of this.